Hi guys, welcome to the 10.3 scatter plots and trend lines video. Alright, let's start off by going over some vocabulary. So first we have bivariate data. That's data that is made up of two different variables. And we also have a scatter plot. A scatter plot is a great visual for two variable data, which graphs points with one variable plotted along each axis. So you have scatter plot is dots all over the graph, and you'll see a trend or no trend at all. You also have correlation. Correlation is a relationship between the two variables, and it's a measure of the strength of that relationship. So when you're looking at a scatter plot, you can tell if the two variables correlate based on how close they are to one another and what trend they're making, whether it's positive or negative, or kind of no correlation at all because it's scattered all over the place. So you can see here a positive correlation for the first graph because it's going up from left to right, negative correlation because it's going down from left to right, and no correlation because there's no pattern at all. So there is also another vocabulary word that you need to understand, which is coefficient, correlation coefficient. And that's denoted by the letter R, and it varies from -1 to 1 depending on how much correlation there is. So with the sign matching with the type of correlation. So a strong correlation is close to 1 or -1, and a weak correlation is close to 0. So if you think about a number line, -1, 0, 1, then the closer the number is to -1, it's a negative correlation. The closer it is to a number 1, which is the other side of the number line, that would be a positive correlation, and that's strong in those two sides. But if it's close to 0 in the middle, then that would be a weak correlation. All right, guys, so for this section, you have to identify the correlation coefficient for each scatter plot using either -1, -0.5, 0, 0.5, or 1. So remember, it goes from left to right. So looking at these dots for number 1, or the scatter plots for number 1, you can see that it's going up from left to right. So that's like this if it was at a line. And it's really close to the line. So when it's close to the line, that means that there's a strong correlation between the data. So if it's close to that line that you sketch on the graph, then you're going to want to use a 1 or a -1 depending on if it's going up or if it's going down. And this is going up, so we're going to use a +1. So it's not exactly 1, the correlation coefficient. We're just estimating for this part of the lesson. So for the second one, you can see that the line isn't going to be anywhere near those points. The points are kind of scattered all over, and there's no real general pattern for that. So we're going to use 0 for that one because that's not close to the line, and it's not kind of close to the line, and it's not negative or positive. It's just kind of all over the place. So there's no correlation for number 2. So if you want to write down no correlation for number 2. So then 3, you can see that it's going down compared to number 1. That one's going up. So that's going to be a negative. And the points are going in a general direction. They're just not close to the line like they were in number 1. So we're going to use -0.5 to show that correlation coefficient. So it's going down from left to right, and it's going in a pattern, but it's not close to the line. So it's not really strong, but it's not a weak correlation either. So we'll use -0.5. All right, so now we're going to actually solve a problem. So it says the number of snowboarders and skiers at a resort per day and the amount of new snow the resorts reported that morning are shown in the table below. So we have a table with X and Y. Remember, your X are going to be 2, 4, 6, 8, 10, and your Y is going to be the number of snow sliders ranging from 1146 to 2490. So it says make a scatter plot with the data. So that's just ordered pairs. So that's kind of a review from the beginning of the year. So we just go ahead and plot those all the way up, 2, 1146, 4, 1556, 6, 1976, 8, 2395, and 10, 2490. So now that you have your points plotted, that's A. B says draw a line of fit on the graph above and find the equation of the linear model. So we have to draw a line that goes through most of the data and it goes through the center of that data. So you kind of want to judge it based on the points that you're given, and that's the direction that you go with your line. And you want to be in the most center, spot possible. It's not a perfect science. So my line's going to look like that. And the more dots you have spread out, the more the line's going to shift left or right depending on, the number of dots that you have. If you have an outlier, that can also affect that line of best fit. And then also we're going to create an equation. So that's, remember, your y equals mx plus b. That was from the beginning of the school year as well. So we're going to put y down because we have that. And you'll notice that 2,1146 at that point and also at 2,395, those 2 points are the closest on that line. And that's what you kind of want to do when you're creating your line, your equation for this line, is that you want to see what 2 dots actually went through that line and use those to create your slope. So remember, the slope formula is y2 minus y1 divided by x2 minus x1. So y2 minus y1 would be 2,395 minus 1,146 all over x2 minus x1, which is 8 minus 2. And then you just simplify that. You're going to get a decimal with this one, so we're just going to estimate it to be 208. So we put 208 next to x because that's our mx part, that's our slope. And then for the y-intercept, we're just going to look at the table, look at the graph. So we know that halfway between 1,000 and 500 is 750, and that's just above the 750 line. So I'm going to call that 800. So we're going to put 800 for the y-intercept, and now you have the equation that matches that line. So for C, it says, if the resort reports 15 inches of new snow, how many skiers and snowboarders would you expect to be on that resort for the day? So now that we have an equation, all you have to do is plug in 15 into x, because the amount of snow in inches is your x value. So we plug 15 into x and we solve, and you get 3,920. So what that means is you'd be expected to have 3,920 skiers and snowboarders at the resort on that day. And that's all for this video. Go Seahawks. Woo!